are still on Unit 4, Random Variables. Now on Section 4, Cumulative Distribution Function of Discrete Random Variable. So here we are dealing with cumulative distribution function of discrete random variable. After that, we will look at the cumulative for continuous also. So what we will be looking forward to, by the end of the section, we should be able to explain what is meant by cumulative distribution of a random variable, construct cumulative distribution function for discrete random variable, calculate probability for that, and obtain probability mass function from cumulative distribution function. Let's get the ball rolling. Definition. The cumulative distribution function of a discrete random variable x for any specified x is, so f of x is giving us probability of random variable x assuming small x as less than or equal to small x. And what it means is that we are summing all the probabilities from xi less or I is less or equal to x. That's what it means. So the CDF simply means cumulative distribution function of a function f of x is obtained by summing the PMF, probability mass function, probability of xi over all possible values of x which satisfy xi less or equal to x. So if x takes on finite number of values, x1, x2, up to xn, then what happens? We'll have probability 0 will take on negative infinity up to xi. Probability of x1 will take x1 up to x2, and in that order to the last one that have the range of xn up to positive infinity. Maybe example will give us a clear understanding of what we are talking about as cumulative distribution function of a discrete random variable. Example 1. A stock room clerk returns 3 safety helmets at random to 3 employees who had previously checked them out. Is Sakite, Jonah, and Butchie in that order? So look at the order. Sakite, Jonah, Butchie. That's SJB. In that order, receive one of the 3 helmets. List the sample point for the possible order of returning the helmet and find the value of x, of random variable x. That represents the number of correct matches. And at the end, we have to find CDF, the cumulative distribution function of x. So you see the order: Sakite, Jonah, and Butchie. So in a simple way, we have S, B, that's J, and B in that order, right? That's the right order. So let's look at the ideal solution. So let X represent Sakite, J, Jonah, and B, Butchie. So in this, the sample event and then the X as a random variable. So we have the first one, XJB. Remember, that is the right order. So X is in its order, J is in its place, and B is in its place. So mean that X is first, J second, and B third. So all the 3 are in the order. So we have X assuming 3. Now look at the next one, SBJ. Only S is in its right position. The B and the J have messed up. So you have only one order. So X assume 1 in this way. The next one is what? JSB. So here it is only the B which is in its right position. So here also you have only 1. The next we have JBS, and none of them is in the right position. That will give us 0. And you have BSJ, also none of them. You have BJX, and in this case, only J is in its right order, so you have only 1. Good. So you see that this is the distribution function now. X assuming values from what? 0, 1, and 3. So the x and random variable x assuming small x for a 0, we have 1/3. Because all the items here are 6. And how many zeros do you have? You have 2 zeros. Out of the 6, that will give us 1/3. And out of the 6, we have how many ones? We have 2 of them. Yes, that will give us 2 out of... we have 3 of them. We have 3 of them. We have 3 of the ones. Another one is here. That will give us 3 out of 6. That is the same as 1/2. And the 3 is only 1. So we have 1 out of 6. You see that the random variable x with its corresponding probabilities. Now for the cumulative, for x less than 0, we have f of x should be equal to 0. God, we will not have any pairing correct. For x equal to 0, we talk about cumulative. Cumulative, like we are adding up. So f of 0 will give us probability of x less or equal to 0. So less than 0 or equal to 0. And you know that probability of less than 0 is 0. And probability of x equal to 0 is 1/3. So for x equal to 0, we have 1/3 as our cumulative probability. For x equal to 1, as f of x equal to 1, we have x less or equal to 1. X less or equal to 1 means that x will be less than 0, x will be equal to 0, and x will be equal to 1. So x is equal to less than 0, we have 0. X equal to 0, we have 1/3. And x equal to 1, we have 1/2. Summing up, we have what? 5/6. So you see, quite interesting. We are left with the last one. That's for x equal to 3, right? So for x equal to 3, your probability will be between 0 and 3. That will be x less than 0, x equal to 0, x equal to 1, and x equal to 3. And for each of them, they have their own corresponding probabilities. And summing up everything, we have 1. So the CDF could be given as this, as you could see in this table, as what we just discussed, giving all those intervals. Quite interesting, right? We could compare again and see. There's also something interesting from our targets that we want to hit. Yes. So the objective, we say that we should be able to calculate probability from a discrete cumulative distribution function. So we were to have, so the initial one we calculated, we were having probabilities and we are calculating the cumulative. We could be given the cumulative for us to extract each probability from the cumulative function. Yes, it's quite simple for us to do. So given the CDF of a random variable x, probability for various values of x can be calculated from them. So let's take example 2. Example 2. Let x equal to the number of days of casual leave taken by a randomly selected employee of a large company during a particular year. If the maximum number of allowable casual leave day per year is 14, then the possible values of x are 0 to 14. So 0 means that you have a 0 day, no day given to you, up to 14. And given that f of 0 is 0.5, f of 1 0.72, f of 2 0.76, f of 3 0.81, f of 0.4, 0.88, f of 5, 0.94. We have to find probability of x between 2 and 5. So that is 2 to 5. And b, probability of x equal to 3. Quite interesting, right? So solution. So probability of x between 2 and 3, or ranging from 2 to 5, would mean that x will assume values of 2, 3, 4, or 5. Now, it's a cumulative before getting to the 5. So what is not part of this is the beginning part, that's the f of 1. So to get from 2 to 5, just taking off f of 1 from f of 5, that's the last number, will have the probability. And you know, f of 5 is 0.94 and f of 1 is 0.72. That gives us 0.22. We talk about cumulative. You know, if you have 2, how do we get the 2? We added 1 and the 2 itself, getting the 2 cumulatively. If you have 3, we added 1, 2, and 3 itself before getting the 3 as a cumulative. It's quite simple, right? Now let's look at the b. The b part says probability of x equal to 3. And this is the same as, you know, x equal to 3 means you're looking at only the x equal to 3. And here the f of 3 is a cumulative from 1 up to 3, or from 0 up to 3. And for us to get exactly the 3, then let's take the cumulative of 2 from the cumulative of 3, then we'll get cumulative, or we'll get only probability of x equal to 3. You get it? That is 0.81 minus 0.76, that will give us 0.05. That is exactly 3 itself, not cumulative of 3. Yes, very interesting one. Thank you very much. We're looking forward to do that with a continuous random variable in the next session.